Hello guys, welcome back to our lesson. So we are going to continue on discussing your distance formula, but this time it's part of the distance formula. We call it partitioning line segment. When we say partition, it means that you have to separate or divide. A line segment can be partitioned into smaller segments which are compared as ratios. So we'll be using the word ratios in this discussion. Partition occurs on line segments that are referred to as directed segment. When we say directed segment, this is a segment that has a distance, meaning there's a length, okay, and also direction. It is important to understand the directed segment has a starting point referred as the initial point. When we do partitioning, we have to make sure and we have to go back on the ratio that is being used on the problem. Now, for you to understand this further, I have three examples here that you can watch and you can use as a review for partitioning line segment. So let's start with the first one. Given the point A is negative 1, 2, and B is 7, 8. Find the coordinate of the point P on directed line segment AB that partitions AB in ratio 1:3. Right? So take note that we are using ratio 1:3. Now, in partitioning line segment, if the ratio is given in this form, we have to convert this one into fraction. So, Mr. How are we going to convert this into fraction? You just add the two numbers and then you copy the first number to be your numerator. So your first number will be your numerator. So this will be 1. And then your denominator is when you add this two number, which is 1 plus 3, will be 4. So we will be using 1/4. Okay. Now, how are we going to solve this problem? First is you have to graph. Do partitioning line segment requires graph all the time? To answer that question, it's no. I'm just only showing you how to graph because I want you to visualize how it looks like to partition a line segment. So first is I'm going to graph my point A, which is negative 1, 2. This will be point A. And point B would be 7, 8, which is 7. And then we go, I'll just making this one, making sure that I point the, so that's 7 and 8, right? So this is now your point B. So if you are going to connect this line or this segment, I would say that this is your line segment here. Now we are going to partition this one in the ratio 1:3. All right. So we are going to do the first one. It's horizontal change. So your horizontal change, this pertains to the value of x. So meaning I'm going to mark that as your value of x. So the changes on x from this point going to the B. Okay, so you see the dotted line there. You just focus there. And then the next one would be your vertical change. your vertical change, this pertains to the value of y. So it pertains to the y change. So if I'm going to graph that again, I'm going to do a dotted line. So from here, from this point, we have to get the change until here. Okay, so that is how we are going to partition. So what is the what will be our formula to get the horizontal change? We start with the ratio given. Sorry about that, it's supposed to be like that. Okay, the ratio given. That's interesting, sorry, so I have to change that. There you go. So we are going to use the given ratio, stands for R. So ratio multiply that by x sub 2, meaning it's the second x, and x minus 1. That's the x on the first point. For vertical change, the given ratio, and then we multiply y, the second point, minus y 1. All right, so let's identify your x1, x2, x3, x1, x2, y1, y2. So your -1 will be your x sub 1, and your positive 2 here will be y sub 2. Your, or x, sorry about that. It must be, this one will be x1 and y1. There you go. This is x1 is -1, y1 is positive 2. And then we have x2 for 7, x2 for 7, bear with me, and then y2 for 8. All right, I'm trying to fit the x1, y1, x2, and y2. So we just plug that in. So the ratio given will be the fraction that we have. So we have ratio is 1/4. Multiply that by x2, which is 7 minus -1. Okay, and then that's 1/4. So 7 minus -1 will give us 8. Therefore, the horizontal change will be 2. I'm going to box this one because we still need this. Okay, we're just only doing the first step of partitioning, right? And then the vertical change would be the given ratio, which is 1/4, and then y2 is 8 minus your y1 is 2. That is 1/4 6, and then it will give me 3/2. That is the horizontal change and the vertical change. Now, what are we going to do now is, it says there that we have to partition from A going to B at a ratio of 1/3. So what I'm going to do is to find the point using the horizontal change and the vertical change. So your step 2, okay, step 2, I'm going to get the horizontal change, which is 2. Okay, I'm going to put a parenthesis because what we are looking now, it's a point. Okay, we are looking for a coordinate, meaning there is a x and y value. I'm going to get the horizontal change, which is 2, and then I'm going to add that with the first coordinate of A. Your A coordinate is this, -1, 2. So the A coordinate is -1, 2. All All right, so this is your X on A, this is Y on A. So what I'm going to do now is the horizontal change, which is 2, plus, okay, the given X value for A, -1. Then I'll put comma here because we are looking for a point, and then go with the ratio, the vertical change, 3/2 plus the Y value on your A, which is 2. And you have to perform the operation. So it says there, find the coordinate of P. So the coordinate of P now would be 2 plus -1, which is +1. And then 3/2 plus 2 will give us 7/2. So this is now the coordinate of P. So this point partitioned your AB in 1:3 ratio. So if I'm going to graph that, okay, I'll use red here. So you have 1 and then 1, 2, 3.5. This is now your P. So if you're going to count from here, that's 1 and 2. Okay, that's 2. And then that's 1. This is 1.5. Okay. Now, if you're going to count this, okay, if you're going to count that, it will give you, that's 1, 2, 3, 4, 5. Let's count. So 1, 2, 3, 4, 5, 6, 7. Is that 7 or 6? 1, 2, 3, 4, 5, 6, 7. I'm sorry about that. It's 6. So that's 1, 2, 3, 4, 5, 6. 6 units. And then, so I'll just use green here, 6 units. And then if you count everything here from A to B, that would be, you have, that's 1, 2, 3, 4, 5, 6, 7, 8. So that is 8 units. So if you go and look at it, you have 2 over 1.5 or 1.5 over up. That's 1.5 over 6. And then 2 over 8. It will still give you 1/4. Okay, so 2 over 8, this one, that is 1/4. And if you have this 2 here, 1.5 over 6 will still give us 1/4. So that is how you do your partitioning line segment.